Hi, welcome everyone. We'll kick off in the interest of time. We were just giving a few minutes for people to join as they may be running between meetings or events. So just to briefly introduce myself, I am the co-founder and I also lead the cyber practice in Stupa. So today we're here to discuss something that is quite interests me. I can be biased because I'm from a security background, but hey, application security has been something that has interested me from my early days in cybersecurity. I started my journey from application security side of things, so it's very close to my heart. I almost call it my baby as well. So yeah, I'm genuinely interested in today's session. So I'll be moderating. I've got my in-house cyber expert on application security who will be taking the stage. So I don't want to be stealing much of his thunder, but just want to build some context around, the change in consumerization at present times is monumental, isn't it? And the speed that it's changing is startling, right? We have everything smart and everything as a service. We've got a refrigerator that is, a smart refrigerator. We have got, autonomous cars that are hitting our road. The change, the shift in consumerization is just amazing. This shows that both the use and the meaning of data has significantly changed over the last decade. Data, in fact, in 2017, the World Economist announced that it was not oil and gas anymore. It's the data that's the most valuable asset in the world. Now, applications and products assimilating, combining various application service components are pushing boundaries at both levels in terms of groundbreaking innovations and the impact it has on lives and livelihoods of the people, right? Whether we take fintech, medtech, biotech, agri-tech, there's all sorts of technical innovations that are making a huge impact in humanity and humankind. So we live in a really interesting day and age at this point in time, right? For that reason, in the current times, I claim that digital transformation to be more sophisticated than just a change in a business ecosystem in how they get their products to the market for consumption, right? But it is a catalyst for this paradigm shift that we are seeing. Like I said, changing lifestyles of consumers and the culture of consumers as well, right? We are seeing different industry verticals are making huge investments in data analytics, data science, as a part of their digital strategies to not just be the modern digital business, but to solve genuine human problems, right? Be it in a biotechnology side of things, be it in medicine, be it in agriculture, be it in just e-commerce, that takeaway that I can now get at my home. I don't have to drive to that restaurant. So providing a different dimension to uplift consumer lifestyle, culture, and well-being. And application is not far from this paradigm shift, in consumerization that we are seeing. In fact, application is that heart of the modern digital strategy, bringing enormous benefits to consumers, right? So with this kind of a little bit of a context in the importance of application security, the day and age that we live in, enterprises are transforming monolith and tightly coupled application stacks into product and technologies that are rapidly changing, processes that are radically redesigned, switching to more CI/CD, continuous integration, continuous deployment, in layman's term, for almost instantaneous changes being pushed to applications as per the consumer demands, that speed to the market, to be the first one to release something innovative, something groundbreaking, right? And security becomes really key in this process. So we're here to talk about cybersecurity aspects, the whole security backdrop around application. But I think it's good to start, with the understanding of how the consumerization is changing, digital transformation landscape, digital strategies that different businesses are taking for innovations. So Abhishek, how about you give some, from your understanding, what is the importance of application for a business in this day and age? Let's start with that before we dive into cyber aspects.
Yeah, sure, Dai. First of all, I would like to thank everyone, three attendees, for for being in our for being here in our webinar, for supporting cybersecurity and cybersecurity related webinars. So us as per you said earlier, that you talked really nice word about application security and how application is being at the backbone of a many business, and I actually totally agree with this. What today's business, actually web applications are the backbone of many business these days. They help in operation of a business like sales, inventories, billing, services, and many more. They The more integrated the web application for a business in terms of a data sharing, usability, and controls, the better it is served as a platform for the growth of the business. In terms of Nepal, we can I am able to see different shift in consumerization in terms of applications. Back in the days when we used to talk about web applications, websites, there used to be we used to talk about different portfolio web application of a portfolio websites of an organization. Nowadays, the application has been changed to a more dynamic, user friendly, user accessible web application. So yeah,
That's great, Abhishek. Thanks for the insight. Like obviously, I'm a Nepali, right? So I come to Nepal not just for my family purpose now, but for business as well. Um, as a consumer, I'm seeing that shift when I come to Nepal as well, right? So I remember, when you come to Nepal, having to carry around a rucksack, or you need to have a deep pockets where you can carry hard cash. The e-commerce was like still very much at ground zero levels, but lately when I visited Nepal, I see there's some really interesting advancements in terms of the e-commerce landscape of Nepal. In terms of, let's say, not just e-commerce, but that whole digital revenue generation side of things. Just a question out of, like in this context is do you think the COVID-19 has been the catalyst, in terms of digital transformation in Nepal, or was the shift already happening, and just, COVID came in to expedite that journey of digital transformation in Nepal? I would say, what are your thoughts?
No, actually, you are right. The COVID has been a very good catalyst in terms of developing application all around in Nepal. Not only a catalyst, but actually Nepal has been on its way to this digital transformation phase. Me myself I used to take cash everywhere. Now we are using different e-commerce applications. We are using different mobile banking services. This has made this is and all this along with COVID has just been a catalyst in improving our technology, improving the ways we interact with application, the way we interact with day-to-day services. So yeah, I totally agree with you there.
That's good to know. That's good to know. Not that you agree with me, but like, COVID has been one of the
Yeah,
one
actually,
of the as well.
yeah, we
So
can actually see the change there. So
yeah, that's really good to know. So without further ado, let's dive into, like, this security of the application security state in Nepal, with this shift in not at a national level that we are seeing in Nepal, right? But at the same time, I'm sure the consumers are also now enjoying the fact that, hey, I'm certainly enjoying, when I'm coming to Nepal, I don't have to carry like so much cash in my pocket. I'm not used to carrying so much cash in my pocket. Um, Now that I can pay online, I can use my Visa cards. I recently saw an update, with phone pay partnering with Visa cards, so that you can use international card to make payments in Nepal. So really amazing. I'm kind of like observing from that kind of consumers landscape perspective as well, and I'm excited about the journey that Nepal is in, right? So without further ado, let's dive into the security backdrop of it. In terms of the state of application security in Nepal, and how is it changing? How is it moving forward in terms of bringing not just the right mindset, but that culture change in Nepal as well. So, that application is not just about getting application in front of your consumers, but hey, it's about getting secure applications in front of your customers, so that you're not just protecting your business, but you're also protecting your consumers at the same time, who are using that applications for. various purposes, right? So
Yes.
yeah, I'm interested in hearing, like your kind of subject matter expert insight into top 3 vulnerabilities that you're going to source today, right? Of OWASP,
Yeah.
um, for just to kind of set the scene. So OWASP, is something. It's an open web application security project. So it's a crowdsourced, a community of intelligent mindset coming together to solve a challenge around the application security side of things. So I won't go into the technicalities of OWASP, but hey, um, obviously the floor is all yours, right? Let's crack on. I'm interested in seeing what you have, and I might have some questions certainly. So whoever is in the audience, if you don't have questions, I certainly do. So, but I do encourage you ask some questions, and yeah, I hope you get some value out of this session. All right,
Yeah.
Abhishek, the floor is yours.
So thank you, Dai. So first, talking about the application security condition in Nepal, with all this technological advancement, with all this internet banking, all this mobile banking, e-commerce coming in the front line as a frontline application has been in the front line of the business. As we can see, people are actually being aware of their data, their information is being tracked or not. So actually in Nepal, people are being aware of what actually the application is doing with their data. So with data and information, as you said earlier, data is now one of the most valued asset in our asset. So as per the businesses have been giving more and more focuses on securing their application. They have been applying different technologies. They have been taking consulting service from different security vendors, different security providers, so that they can provide a safe and secure application in Nepal. So further ado, let's start with OWASP. So as Ashish just gave a short introduction of Open Web Application Security Project, what it actually is. Today I will be presenting some insights into top 3 vulnerabilities of OWASP. So uh, let me just get started with it. So I hope my screen is visible. So okay, first thing first, the first vulnerability that has been listed in OWASP is broken access control. Broken access control has moved up from the 5th position back in 2017 to number 1 in 2021. According to OWASP, 94% of the application has some form of broken access control vulnerability within them. A computer system is designed to be used by multiple users, each with their own privilege. Privilege means what a user is permitted to do in a system. Common privilege for a user includes viewing and editing files, modifying the file systems, and applications are overall designed to let users access, modify, and update the data as per the need. The broken access control vulnerability is an application level vulnerability where an attacker can access the data of other users without any intended permissions. So the, what happens here is the broken access control vulnerability is actually the flaw in authorization, not in the authentication, but in the authorization which will lead the anomaly, which will lead the adversary or the attacker or the hacker to gain access to the private and confidential data of an organization. This vulnerability could lead to an unauthorized information disclosure, modification, destruction of the data. In most cases, the hacker has created a request for in most cases, the hacker has to create a request for a content or a function that they are not permitted to access. Once the flaws has been detected, the impact of the broken access control vulnerability can range from mild to severe depending on the content's severity and protection control. So there are different access control vulnerability. There are different ways to trigger an access control vulnerability. First thing is the vertical privilege escalation. Vertical access control can be explored to access the function that the ordinary user cannot access, such as modifying or deleting the user accounts. So moving on to the horizontal privilege escalation. Horizontal privilege escalation Horizontal access control enables the attacker to access the resources belonging to other users. This could happen because of improper implementation of the ID controls in the URL parameters. So, and the context-dependent privilege escalation. It is kind of a mix of a vertical and a horizontal privilege escalation, where the attacker will be using both of the techniques. So, in the context-dependent privilege escalation, the attacker compromised privilege users to turn horizontal privilege escalation attacks into a vertical privilege escalation attack, as I talked earlier. For instance, a hacker may use a broken horizontal control to retrieve the login credential of another user, and the attacker can then target the administrative account, which gives them the administrative right to escalate the privileges vertically. So for more understanding of the broken access control vulnerability, I will be talking about the IDOR vulnerability, that is insecure direct object reference. Insecure direct object reference vulnerability means that the application is directly exposed. If you can see the application, the application directly exposes a reference to an object exposes a reference to an object which could lead to something like a file or user details that could be accessed regardless of any kind of authorization. As I talked earlier, access control vulnerability is a flaw in authorization. So an anonymous user or a attacker could just access any kinds of files or user details, or can modify the user detail parameters without any kind of authorized permission. So for an instance, if the web application was directly using the user input to retrieve the user information without an explicit authorization check, then there the attacker could simply change the value of another user ID and get all the sensitive information. What I meant by this is, let me give you an example. So in this diagram, I've created a little illustration of a little attack scenario. I'm using attacker in the name Bob and a user named Alice. If Bob sends a request to the web application, then the request would look something like this in the top end of the slide, where the user ID of the Bob would be shown like 266. What if the user ID of the Bob is just changed or escalated to 267? Then if the application is vulnerable to broken access control, then the application will just give the response with the personal information of Alice. That means whenever the user Bob just changes the user ID parameter 267, that means the attacker will be able to gain access to the information of user. So how can we just fix this vulnerability? This is a very simple and a very this is a very simple vulnerability, and it could have a very devastating effect in a web application. To fix the above issue, we could use to fix this. A server has to give a session cookie, and then just look up this. To fix this, the server has to give some kind of session cookies and then look up to the user ID in the backend instead of just blindly accepting. As we can see, the application is just blindly accepting any kind of user ID. Instead of blindly accepting any kind of user ID, we need to first validate. We can use any kind of session cookies instead. Or if we are using any kind of serverless architecture where the user ID is taken directly from the client, then the server needs to have some sort of protection against tampering the data by including some sort of signature like JWT or JSON Web Tokens. So there are different preventive measures that we could use to mitigate the broken access control flaws. Like we could enforce the principle of less privilege. What this means is, the principle of less privilege is the concept that where a user should only have the access to what they absolutely need in order to perform their responsibilities, and no more than that. The more a user gets, the more a given user has access to, the greater the negative impact. That means we need to have some sort of access control implemented where the user should only be given the permission that he or she absolutely needs. So we can also enforce different kinds of role-based access control mechanism. We could, since today's application is very dynamic in nature, they take different inputs. So they are using different kind of APIs to interact with different components. They are using different kinds of APIs to interact with different components on an application. We could use rate limiting on an API. We could use multi-factor authentication on all access points. Or we could even just shut down any kind of access point that is unnecessarily there on that application. We could just eliminate any kind of services that is not needed on the server. So these are some of the broken access control flaws. Hope I'm able to understand. If you have got any kind of question related to broken access control, I would be very happy to address it. So moving on to the cryptographic failure. The cryptographic failure, which is listed as the number 2 vulnerability in the web application, previously listed as the cryptographic failure, which is listed as the number 2 vulnerability in web app in OWASP 2021. Previously, it was listed as number 3 with the name sensitive data exposure. Cryptography is simply a cryptographic failure is related to the failure related to any kind of cryptographic algorithm or any kind of cryptography related issues. A cryptographic failure refers to a problem within the cryptography or any kind of absence of cryptography altogether. Previously, this vulnerability was named as a sensitive data exposure, but this name was not entirely accurate as it describes the symptoms and it describes a symptom and an effect rather than a cause. Cryptographic failure may often does lead to exposure of data. So sensitive data exposure is an outcome of a cryptographic failure. So while understanding cryptographic failure, cryptography itself is a very vast domain. We need to understand different kind of different kind of encryption algorithm. We need to have concept of key management, where we need to have concept of CA certificate. We need to have concept of certificates. We need to understand what kind of data does an application have. For this, for this in an application, there are two kinds of data, one at transit and one at rest. A data in transit or the data in a motion is a data that is actively moving from one location to another, such as across the internet or through a private network. Data at rest is data that is not actively moving from devices to devices or a network to network, such as data is stored on a hard drive, laptops, flash drives, or any kind of archive stored in some other ways. So to understand cryptographic failure a bit more, I have made a little illustration of a little scenario. For a cryptographic failure to happen, whenever a web application makes a request to the database server has every kind of information that the user has kept in a server. If the data of a user is encrypted at the database server, then the encryption is called encryption at rest. But if the database server is automatically decrypting the data before sending it to the web application, then this architecture has a little flaw, because here the attacker may just retrieve the data using a simple injection technique or simple Xss attacks and just grab to the user's information. So in order to understand cryptographic failure a bit more, we need to understand what a sensitive data is. A sensitive data includes any kind of information of a user and an organization that may be original or a copied version. This information could be something like biometric data or a person's health data or a political belief or ethnic origins. For a company, it could be something like a client's agreement with client, their different terms and agreements, the different policies, their internal policies. So there are different components that comes into place when we talk about cryptography. We need to talk about key management, how the key is being managed, because key management is one of the most important topic in cryptography. We need to understand how the key is being managed, where the key is being stored, what kind of cryptographic method has been, what kind of encryption algorithm is being used to encrypt the data at rest, or any kind of or we need to understand that. Okay, there are different ways we could prevent cryptographic failure. Like we could use standard crypto libraries like Google Tink or using Lipsodium. It is always better not to write a cryptographic algorithm by ourselves and use a proper cryptographic library or standard that has been out there. So we need to understand about we can use different HTTP headers or security directive, some directive that could help us mitigate cryptographic failures. So moving on, there are different cryptographic failure may include there different components like storing a data in a clear text. That means no encryption has been used. That means if a user is able to use any kind of attack like injection attack, and they could just get the data out of the database server clean text. If we if we're using outdated or weak cryptographic algorithms and protocols, then the cryptographic failure may arise. There are different ways. If we are not validating the server certificates properly, if we are ignoring and reusing the initialized vectors, or in using an insecure mode of operations, there are different components that come into play while in the cryptographic failure. But we could use different prevention method. We could use different preventive measures to mitigate these issues. Like we could implement a security control depending on the data classification, as there are different data in our application. Some could be highly confidential, some could be confidential, some could be just informational data. So we need to implement security controls depending on the data. We could just we could use different we could use SSL or TLS to encrypt data at transit, so that any attacker that is doing man in the middle would just get a gibberish data. We could use different HTTP header or directives for encryption. We need to use different kind of encryption algorithm to encrypt data at rest. So basically this is cryptographic failure for as per the OWASP. So any questions regarding cryptographic failure? You could just use Q&A section to paste your questions, and I will address at the end of this session. So the number 3 vulnerability of today's OWASP is injection attack. One of the most heard and known vulnerability that has been staying on the top of the list for a while now has now finally been listed as the third most used vulnerability in an application. A lot of time when we talk about the injection attack, we hear people talk about Sql injection, but injection vulnerability is much broader than this. What actually an injection vulnerability is? It is a flaw where the web application is taking any input from a user, which is resulting to a malicious activity, like the attacker is able to dump a whole database into the system. The attacker is able to see all the information about the user, able to list all the users present in an application. There are different forms of injection attack that could happen, like SQL injection, cross-site scripting. Actually, cross-site scripting is not an injection attack, but as per OWASP 2021, cross-site scripting has been listed alongside injection. So I have included cross-site scripting. So it is a kind of injection attack now. So there we can use different kind of injection attack like LDAP injection, NoSQL injection, CRLF, carriage return and line feed injections. We could use OS command injection. So I will not be describing all of these injection vulnerabilities, but rather focusing on the top two vulnerabilities like SQL injection and cross-site scripting. So starting with the SQL injection. SQL injection happens when a user manipulates with a query that is sent to the database. This would allow an attacker to view data that they are not normally able to view or retrieve. The attacker can modify or delete this data, causing a persistent change in the application's content and behavior. In some situation, an attacker could escalate an SQL query. Attacker could just escalate an injection attack to compromise the underlying server or any kind of backend infrastructure, or even perform a denial of service. A successful SQL injection attack could result in unauthorized access to sensitive data such as password, credit card details, personal user information. Many high-end profile breaches in recent years has been due to the result of a successful SQL injection attack. In some cases, an attacker can obtain a persistent backdoor into an organization system, leading to a long-term compromise that could go unnoticed for an extended period of time. Okay, talking about a real-life SQL injection attack, there was recently a threat actor stole stole 8.3 million emails and password access from FreePic and Flaticon users using a SQL injection attack. So SQL injection is kind of a since SQL injection has been in the list of OWASP from a very long time. It was in the #1 list. It is still in top 3 vulnerabilities. So how does a SQL injection work? I have just created a little scenario trying to explain what a SQL injection attack looks like. So first, if let us consider there is an application where the user has a login page. Whenever user submits their username and password in an application, the application processes the request as an SQL query, which could be something like this. And what happens here is if an attacker injects a malicious SQL query in between the query that has been sent by a legitimate user, then the web application could respond in a different way. Like in an example where I am able to log in with an admin privilege using double dash. What a double dash does is it is an inline comment sequence that is used to remove all this query after this end statement, after this double dash statement. What this looks like in a real life is, let me give you a live demo of what this looks like. So I hope my screen is visible. Okay. I am using DBWA as an demonstration platform to showcase how the vulnerability actually works. So in this section, as we can see, we are using we are able to provide a user ID to an application. Then application processes the user ID in the backend with the database and provides us with a result like ID, first name, and surname. For a successful injection attack, maybe I could use something like, okay, I just used a single quotation to know if the application is vulnerable to SQL injection or not. After submitting the data, the application might process it differently. It might give us an error or something like that. So application just gave us the error, which indicates that the application is vulnerable to SQL injection. So if I just provide the application with a query something like this and submit my data, then all of the users that has been in the application is listed listed below. So this is a live demonstration of how a SQL injection attack works. So as I talked earlier about this scenario, so there are different kinds of SQL attacks. Like the one I just performed is a basic SQL injection attack. For instance, we could use a blind SQL injection attack. What a blind SQL injection attack is, that means that the application does not resolve any kind of SQL query or detail of any database either within its response. Blind SQL injection vulnerability can be exploited to access unauthorized data, but this technique is involved. But the technique involved are generally more complicated and difficult to perform within an application, depending on the nature of the vulnerability and the database involved. We could use something like time. We could use something like we could use a conditional time delay to process the request in processing the request of a query and evaluate the time before and after the attack has been performed. And similarly, the union-based attack. What happens in a union-based attack is we use a union keyword that lets us execute one or more select queries and append the result to the original query that will be given to us. So now talking about the cross-site scripting. Cross-site scripting, also known as the Xss attack. Xss attack is a web security vulnerability that allows an attacker to compromise the interaction that the user have with a vulnerable application. It allows an attacker to circumvent the same origin policy, which is designed to segregate different websites from each other. Cross-site scripting vulnerability normally allows an attacker to masquerade as a victim user to carry out any actions that the user is able to perform and to access any kind of user's data. If a victim user has privileged access within the application, then the attacker might be able to gain the full control over an application's functionality and over the data. So access in cross-site scripting, the attacker masquerades as a legitimate user and tries to access the data. So how this happens is there are numerous ways, like the reflected cross-site scripting attack. What happens in a reflected cross-site scripting attack is whenever the user opens the link that the malicious user sends to the victim, if the victim opens the link, then the JavaScript will be executed which would then reflect the output to the user's screen, and also could be scripted in a way that the browser sends the data to the attacker. So this is a very basic kind of cross scripting attack that we normally see. Let me give you a live demonstration of what a reflective cross-site scripting attack might look like. So I'm using DVWA as a reference for demonstration for the demonstration purpose. So in this page, we are able to see that the application is asking us a new username, asking us a name. So if I use my name and submit the data, the application is giving me the output hello and my name. So what if I am able to insert a malicious JavaScript and just pop out a different result? Then this is a reflected cross-site scripting. Let me just show you an example. Whenever I just so as we can see, it is giving me an alert with a message. I could just change the message to something like a documented cookie to give me the cookie information of the actual user that is being logged in the application, just like this. So now moving on to the next cross-site scripting attack, that is stored cross-site scripting. Stored cross-site scripting is happens whenever the user opens the link that the attacker would send. The JavaScript file will be executed just like in reflected cross-site scripting, but the JavaScript file does not only gets reflected but is also stored in the database. That means whenever the user that could be the next user or any other user that is logged into an application and goes into the specific page, then this script will be automatically triggered, and the vulnerability and the script will work as it is supposed to work. So this is also the reason why it is called a persistent cross-site scripting, because it is showing a persistent because it is being stored in an application database. One of the most frequently targeted web applications for this kind of attack is could be something like a blog page or social network page, video sharing platforms, or any kind of message boards. So let me also give you a live example of what a stored cross-site scripting might look like in the real life. So similar to reflected cross-site scripting, but the script will get stored in the application database. Like if I insert my name and sign up, just like this, this message is being stored in the database. And if I just inject a malicious JavaScript in the name section of this page, just like I used earlier, and submit the request. As we can see, the application is giving me the current user, the current session ID of an application. So the attacker could just use this session ID to log in and masquerade as a legitimate user and steal more data from the user and just log the actual user out of the account and do an actual account takeover. So moving on to the third and the final cross-site scripting technique is the DOM-based cross-site scripting. The document object model is a convention used to represent and work with the object in an HTML document. All the HTML documents are associated as a DOM that consists of an object which represents the document properties from the point of view of a browser. That means we will be using a legitimate HTML tag that is being used in an application to run our script in an application. So what this looks like in a real life example is, let me just show you quickly what this looks like. So just like in this web page, it is using, I'm able to choose different language here, like French, Spanish, German. But if I'm able to inject a malicious cross-site, malicious script like something like before, that would give me a user cookie, like so. What this statement does is, I am using an image tag where the source is not defined, and if the source is not defined, the image tag, there will be an obvious error. And I am using a JavaScript to provoke that if there is an error, then give me this, then use this, then initiate or run this JavaScript. And what actually happens after that is it will give me a user's current login session. So this is all about cross-site scripting, and we will be now talking about the preventive measures to stop this kind of attacks. Like in SQL injection, we can use different preventive measures, like we could whitelist for a login verification on every user's provided inputs, or we could just encode all the input before sending them to the interpreter, or we could just sanitize the input that the user we in a SQL injection we never what we do is we never take input directly from that application without sanitizing or validating whether the input is correct or not. So these are some of the prevention mechanism that we could use to prevent SQL injection attacks. Similar to SQL injection, we could use something like blacklisting, filtering, or whitelisting to prevent cross-site scripting as well. We could just use input validation just like an SQL injection attack, or we could use content security policies to just mitigate or prevent the SQL injection attack as a whole. So this is my take on this is my presentation. This is my presentation on OWASP top 3 vulnerabilities. So in this session, I have just given a general understanding and help understand what the OWASP top 3 vulnerabilities are. So if we have any kind of question related to these vulnerabilities, I'm very happy to answer those questions and address the queries. Furthermore, you could also just contact us to know more about these vulnerabilities and help mitigate or prevent any kind of uh, harms that could cause using the vulnerability. So over to you, Asistai.
Hey, Abhishek, thanks very much. Hey, that was quite insightful. I was, I was actually following through some of your illustrations of the vulnerability, and like you using DBWA to also exhibit some of that in a kind of hands-on manner. So there are a few questions on the Q&A. So let me put that forward. I think you're saved, Abhishek. I was going to ask you some questions, but there are some questions from the attendees. So maybe let me put that forward first. So first question is, are any older weak cryptographic algorithms or protocols used either by default or in older code? So, I mean, I think the question, just looking at the question, the cryptographic. Let me take on this question first, and obviously you can add to that, I suppose. The question around weak cryptographic algorithms or protocols used either by default or in older code. It's part of, I suppose, a development life cycle as well, right? It is about the whole point about looking at application security or code security is about securing that software that you have, whether it be a web application or whether it be something else, right? As a part of that development lifecycle, like any other information service asset, we need to make sure that our cryptographic algorithms, protocols used by our applications are kept up to date as well. It's not just about safeguarding the crypto keys. It's not just about proper implementation of crypto keys, but it is about, have we got the right register of what cryptographic algorithms are being used by what applications where, right? Dependency on that. Also, there's a compatibility issues. You've probably seen sometimes there are applications that cannot, communicate at TLS 1.2, and with the new changes from modern day browser, these applications were having some challenges. When Google Chrome said that they will not, support the websites with the newer cryptographic security, the cryptographic controls for transport layer security side of things. So I think the question is, it's about, yes, the use of older cryptographic algorithms protocols does exist, but like any other technology stack, it is the responsibility of the business, of the product owner, to make sure that those algorithms, those protocols are kept up to date, keep abreast of what protocols, algorithms are going, end of life or are obsolete or has been now, broken into. And we have to have a equally strong and robust process in place to now change those protocols and algorithms on our applications, right? Obviously, we have to test dependency around
Exactly.
User experience side of things, but yeah. So I'd answer it. I'd answer it in that manner. Obviously, do you want to add anything else?
Yeah, exactly. We need to there. It is not only about using the cryptographic algorithm. We need to always use the updated and the newer version of cryptographic algorithms, so that if there are any kind of flaws, then it could be automatically patched and send it to us. So for this we could just talk about the vulnerable version of OpenSSL, where we could see Heartbleed attack. Heartbleed. It was a flaw in a there was a flaw in a code itself that would lead to a sensitive data exposure. So yeah, I think that is pretty much it.
Yeah, so it is more about the process, right? I think it's less about like it's less about binary. Is it code? Is it the default code? It's more about, when you're building it, having a secure software development lifecycle, and as a part of that, having a cryptographic key management process is important. And as a part of that process is where you maintain, what protocols, what algorithms are you using, when is it going end of life, so that you can start that process in replacing that at the right point in time as well. Okay.
Exactly.
Moving on, there's a second question, Abhishek, and maybe you can. So either the received server certificate and the trust chain properly validated or not. I'm not sure I fully understand that, but again, if we're talking about the SSL certificates, using a CA signed certificate is quite important, right? And how those especially if for your public facing infrastructure or application infrastructure, and securing data both in transit and at rest, using a public CA certified certificates are important, rather than self-signed certificates, which is fine for dev environments, UAT side of things. Yeah, so I don't fully understand that question at this point in time. So there's a third question, obviously, how to detect SQL injection in my website stroke web server. I'll let you answer that.
Okay. So there are different routine application audits that we could use to determine if the application is it is vulnerable to SQL injections. Like I said earlier, we could use different kinds of if we need to use different kind of different frameworks, different up-to-date frameworks. If we're building an application, then there is automatically there will be automatically it will automatically help us to secure an application. But we could use different kinds of attack techniques, like I talked earlier, to see if the application we could inject different kind of SQL queries into different input fields, so that we could see the response that the application server gives us, and we could just we could just use a little fuzzing to get to know more about the application and see if it gives us the result that SQL attack would give us. So I think it's pretty simple to know if the
Okay.
application is vulnerable to SQL injection or not.
I mean, there are various ways, right? There are OWASP, cheat sheets that you can use to test. There are simple blind injection cheat sheets that you can use to test. Without having to point a scanner that might chew up the bandwidth of your application or the whole web stack. So, but then there are some a kind of basic, free scanners available as well. I would not say, fully rely on those free scanners, but do definitely look at OWASP resources. There are plenty of cheat sheets, and yeah, if you get in touch with us after, I'll share the contact details. Maybe we can also share some of the cheat sheets with you as to how you can test SQL injection for your own website. Okay. Last question. Does input validation completely remove SQL injection? So Abhishek, do you want to answer that? And I can add that. I can add if need be.
So it does not completely remove the SQL injection, but it helps mitigate some form of SQL injection attacks. So I would say it would not completely remove SQL injection flaws in an application. We need to use different other techniques as well. We could just use a standard, as I mentioned earlier, we could use standard application development framework so that there is a more secure codes that we push in an application. So I think that is the answer to the question.
All right, thanks, Abhishek. So to add to that, I think input validation is only one layer of defense, right? Putting your all eggs in one basket is what I wouldn't advise. You obviously security is part of layered defense. That defense in depth architecture. So the same goes with prevention against injection attacks. Whether it be scripting, whether it be injection at a database level or even at a LDAP level, right? So in terms of SQL injection, it's also about looking at sanitizing the output before you actually present it to the client, right? You have to look at the output sanitization side of things. The other is also using parameterized queries. Do not your application not processing the arbitrary input from the end users as a part of that query and sending it to the database. So you have to parameterize your query. You have to bind your queries that are going to your database. You can't leave it vulnerable where I can put an arbitrary text or arbitrary query in, I don't know, a email field or a username field, and it actually process that as a part of the query, right? So combination of input validation, output validation, first line of defense, but more permanent or more rather convincing fix is using binded queries, but parameterized queries, for
Right.
your database side of things. Okay. There's another question actually, obviously, so I'll take this as one last question. I don't think we can do a demo today because just in the interest of time, right? We've almost hit the hour mark. So can attacker perform injection attack in MongoDB? I can't see why. It's just another database at the end of the day, right? So to assume that injection attack can only be done in SQL is a myth, right? So injection attack can be done in various databases as well. Demonstration side of things, maybe we can take that, and in our next webinar about there's quite a lot of questions about injection, so maybe we can have a dedicated a deep dive on injection attack and how to prevent injection vulnerabilities. We can have a deep dive webinar session in the future because we'll be doing this more often. We'll take that into account. My team will definitely keep that.
Actually, I would like to add something on this. So injection, as I told earlier, injection attack is not only about SQL injection. We could do no SQL injection to some database that does not take SQL queries. To be precise in this answer, so MongoDB we could do some NoSQL and injection attacks. There are different techniques that we could apply to perform this attack. So thank you, Dai.
Yeah. Cool. Listen, it's been interesting, right? It's been fantastic. Like I said, enterprises are transforming, monolith applications, and they are not just transforming their applications, but the application itself, is a conduit to serve your consumers, right? Whether it be a portfolio applications or you have a proper dynamic applications where you are taking, you're selling stuff, you're taking payments, etc. Right? Application is key of any organization. For any kind of businesses nowadays, be it an innovative startup, big corporate, or mom and pop shop, right? There is some sort of application to interact with, and to give that clients and consumers a space where they can interact with that business and brand, whether it be a portfolio only website or fully interactive, website, web application. The key message that we want to give in a kind of a layman's term is you must take measures to protect that site, its content and its reputation from loss and harm. It's not just for a website that is taking payment. If it's your portfolio website, right, I can take over that website if you don't take cybersecurity seriously of that website, right? Your code level security side of things, web server security side of things, I could take over it and I could bring reputation damage to your organization, or I could use that as a channel to spread my whatever. If I'm an activist, right, spread my message, or to spread my malware. All right, so this is something that I want the attendees to understand, that the websites, application security is not just for businesses that take payment card or that are selling stuff online or that has got interactions, like interaction space, whether it be as simple as contact us page, right? So cybersecurity is more than just a nice to have in this day and age. It is an integral part of your operational resilience. It's an integral part of your financial resilience. It's an integral part of your reputation resilience as well, right? Let's take that into account, right? So with the rapidly changing application development landscape, as businesses are moving more into DevOps, developers are becoming more and more powerful. Everything is pushed as code at the moment, going into CI/CD. They are not going into this waterfall mode. Oh, we have a release cycle. There is a CI/CD pipeline that is now almost instantaneously pushing changes out there for consumers to interact with, for clients to interact with, right? Who wants to be the first in the market to introduce a product? So agile and lean security is now synonymous when it comes to success of an organization. Bolting security as an afterthought, or a non-functional requirement, I would say it's a dinosaur. It's just days of past. Those were those, like, oh yeah, hundreds of years ago, tens and 20s years, like centuries years ago or decades ago, we used to do that. It's a thing of a past. So with that, I'd like to share something with the attendees, where if you go to stupa.io vulnerability-management, you can sign up for our free vulnerability management, and yeah, take benefit of it. Secure your application, secure your code, and like I said, this is part of our responsible business movement. So thank you very much for everyone joining us for just over an hour. Obviously, a great presentation. Really like the illustrations and a demo of the vulnerabilities. So let's call this session to an end.
Yeah.
Thank you very much.
Thank you, everyone.
Bye.
Thank you. Happy hacking. Bye-bye.